I'm not having very much luck. I'll just draw it again. Okay, so on your index card, let's put your name on it if you haven't already done that. And then I want you to write across the top order of filling for electron configuration notation. So put that across the top. And then I'm going to flip this sheet so I can write it big so you can see it a little more clearly. Kyle, why are you always tired after lunch? All right, so on your card, I want you first just to write what I'm putting up here. Put that on one line and then come down, and on the next line you'll write that, and on the third line and this has to do with all the orbitals we talked about yesterday. Okay, so first get that on your card. And then once you have that on your card, I want you to go through and I want you to draw arrows the way that I'm doing it. And it's really important that you get them in order. And then once you have your arrows in, you're going to go through and you're going to write the numbers beside them. So all of that should be on your index card. Okay, so when I look at this, oh, wait a minute, not everybody's done. All right, when I look at this, the number out front, we know, like the 1, the 2, the 3, and so on, tells me the energy level. The letter S, P, D, or F tells me the orbital. All this number out here is to tell you the order it fills in. So I start at 1, I would fill this with electrons, I would hop up to 2, fill, hop up to 3, fill. So it's important when you get to the bottom of an arrow that you hop to the next one when you're doing configuration, and you'll see what I mean in just a second. So just kind of keep that out on your desk, and then also pull this out so that you've got a bit of a map to follow. And then we're just going to put some examples in your notes today and stop and break into little groups and work on some. So let's write in here in your notes, electron configuration notation. It's a long name really for mapping the location of electrons. And the big thing we have to remember is we must follow the 3 rules that we used yesterday, or we looked up yesterday. Off-ball principle, Pauli exclusion, and Hund's. Remember we looked those up yesterday right before you left? So I want you to flip back in your notes to where you write that stuff down when you get done with this, and I'll just go through them real quick and you can make sure that yours agrees with what I'm saying. All right, so off-ball principle I gave you first basically just says an electron occupies the lowest possible energy level. Check what you have written down and make sure it matches that. Electron occupies the lowest possible energy level. Are we good? Do you need to write anything down? Anybody not know what I'm talking about? No? Okay, Pauli exclusion principle. Noah, read me what you wrote down for Pauli exclusion.
2 or more identical particles with half-integer spins, an example, fermions, cannot occupy the same quantum state simultaneously.
Okay, does anybody have anything different than that? No? Okay, let me say that in like normal language. No 2 electrons can occupy the same location. That's basically what it's saying. The exact same location. They can be in the same orbital, but they can't spin the same way. So Pauli exclusion, no 2 electrons can be in the same place at the same time. Make it simpler. I think we maybe better jump back to the off-ball principle. Is that first? Yeah. Yeah. Haley, read me what you wrote down for off-ball.
Dictates the manner in which electrons are filled in the atomic orbitals of an atom in its ground state.
Okay, so if you have something similar to that, again, that's a lot of language for something pretty simple. Let's make it simple so we remember it. So let's just say electron fills the lowest energy level first. That's really simplifying it. Electron fills the lowest energy level first. And that was off-ball. I remember what I'm talking about. Well, I'm really curious to see, I didn't realize you would get something quite that complex. I'm curious to see what you got for Hund's rule. Tayden, read me what you got.
Every orbital in such shell singly occupied with 1 electron before any 1 orbital is doubly occupied.
Okay. So what that, remember the orbital was just the line, like a fill-in-the-blank line? That means every line, like in a P, if I have 3P, that's 1, 2, 3. I call it the sharing rule. Like when you were a little kid and your mom gave you a pack of M&Ms and you had to share them with your 2 brothers. So you did that like 1 for me, 1 for you, 1 for you, and then 1 for me, 1 for me. Well, maybe not 1 for me, 1 for me. You might have tried that, but your mom might have caught you. Anyhow, everybody gets 1 before anybody gets 2. So if I'm looking at something like 3P, before I would do this, no, I have to give everybody 1. And then if I come back and I have enough, then I can fill in. So maybe for Hund's rule, just call it the sharing rule. Everybody gets 1 within an orbital before anybody gets 2. Everybody gets 1 before anybody gets 2. All right, now let's start using some of this stuff. We're going to start simple. I'm going to write down an element. You're going to give me the atomic number of that element. What is it? Nitrogen is atomic number?
7.
Okay, good. 7, which tells me it has 7 protons and 7 what else? You okay there, Evan? Okay, 7, did you say, what'd you say? No, electrons. So we know nitrogen has 7 electrons. All I have to do is look at the periodic table, get the atomic number, that tells me the electrons. Now, we're going to map the electrons of nitrogen so that we know where they are, or most likely are, within the atom. And I'm going to look at my card, and when I look at the card, where do I start with like, to begin? Where's my number 1 tell me to start? 1s, good. So I'm going to look at this picture I gave you because it helps me set things up. You're going to leave yourself some space, start a few lines down so you've got enough room. So I'm going to write down my 1s, and how do I represent the part that holds the electrons? What do I use? It's like a fill in the blank. I just use a line. We're not going to worry with drawing a whole box. We're going to use a line. That's the common way to do it. So this is 1, the first energy level. This is the s orbital. See if you can remember. What's the shape of the s orbital? Yeah. Yes. Spherical. It's round. It's the simple one. The s orbital has 1 orbital location. How many electrons can that hold, Jacob? 1 plus. Every orbital can hold how many electrons? Tayton's giving me the peace sign. 2! 2! It can hold 2! So you know what I'm going to do? I'm going to put my electrons in there. I show my electrons. They're like half of an arrow. Oh, do electrons like to be next to each other? No, why not? They repel each other, so one spins one direction and the other one spins the opposite direction. So I show them like this. There's 1 electron and there's the second. Oh, how many electrons is that? 2. So I have to subtract 2, which now leaves me with 5 electrons. Got to keep track of your electrons. Now look at your card and see what fills next. 2 what? Okay, so I'm going to write 2s just like it is on this paper. See how it's above the 1s? So I just go up to my next line. If I had notebook paper, I would write 2s. I would draw my orbital location. And Kyle, how many electrons can that hold?
4.
S can hold how many?
Or
2. Okay, so 2. So I would go and look and go, do I have 2? Yes, I do. So I'm going to go ahead and put them in. Subtract my 2, and that gives me 3 electrons. Yes? Am I doing my math right? So, Lexi, after 2s, what fills? Okay, so let's deal with our 2p. Now notice how the 2p is a line up and a little bit over. So that's exactly what I'm going to do. Up and over. And I'm going to write 2p, and I'm going to draw my 3 orbitals, because p has 3 orbitals. How many electrons can each orbital hold? Ty, how many electrons can each orbital hold? How many? Nope, how many can each one? I just didn't hear you. 2. So I've got 2, 4, 6 I can possibly put in there. You're right. I'm going to go up here and look. Do I have 6? No! Ooh, what rule do I have to follow? Which one of those 3, Jacqueline? Hund's rule, the sharing rule. Everybody gets one. If I have enough, and yes, I do. Nobody gets two in this case. If I do my subtraction, I have 0 left. That's where I want to be. So when I see this picture, if I didn't tell you all this, if you see a picture like this, and I ask you, what element is this? How could you figure that out? Yes? Yeah, you add up all the things. What are the things? The arrows. You just count the arrows, and then you go to your periodic table. What else can I ask you? What is the highest energy level, just energy level, that contains electrons? You only got 2 choices. Highest energy level, that means the one farthest from the nucleus. What do you think, Kyle? Which one of these is farthest from the nucleus, 1 or 2? 2. So the highest energy level that holds electrons is 2. What is the last orbital that fills with electrons? Again, we only have 2 choices, S or P. Which one filled last? Adam? P, exactly. So there's lots of questions. I could say to you, if all P orbitals were filled, what element would I have? Ooh, we got to add 3. What's 7 plus 3, people? Don't be getting out your calculators now. What's 7 plus 3? Adam? Neon, which is atomic number 10. Caden, I'm going to get you. No. Okay, so let's try another one. Let's try one that's a little bit harder. All right, what got over there? Let's try, I'll have you try it all by yourself.
Oh, no.
You want to do another one together, or do you want to try it alone?
I don't know.
Let's try it alone. Be brave, you can do it. Calcium. How many electrons does calcium have? What's its atomic number? You should all know that. 20. So it has 20 electrons. Try it. Follow your card. Follow the picture.
Can you do this with like 100?
Sure you can. It goes on and on and on. It can get really long and involved.
Do we go that far?
Nah, probably not.
Thank goodness.
Take your time, get it right, and when you're all done, stand up. I just thought, where's she going? Takes a minute, doesn't it? Wait till you do 54.
Oh.
Okay, so now I want you, just somebody that's around you, take your paper and kind of compare it to them. And then let's compare to what I'm about to put up front. See if they look alike. All right, once you've checked, sit down. Okay, did you agree with each other?
Indeed.
Raise your hand if you had trouble with that, and be honest. Anybody feel like they had trouble? Think you got it figured out? Did yours look like mine? Did you end in 4S2? Okay. All right, so now I'm going to ask you a question. I'm going to give you one. I'm going to ask you some questions about it. So you might want to maybe just write the answers to your questions in your notes. I don't know. First, I want to know what element this is. Be good if I figured out what element it is. I got my glasses. Raise your hand if you know what element it is. Really? That's all? Okay, Evan, since that made me laugh, I'm going to pick you. Manganese. How, you got the rest of you who raised your hand, did you think manganese? You did not?
I did.
You did, okay. So, Evan, tell me how you figured that out.
I counted the 12 arrows.
I
Not sure I understand.
Siri.
She goes off way too much. I think you're right. You just count up the arrows. Yeah?
Yes.
Okay, so here's my next question for you. What is the highest energy level that contains electrons? What is the highest, it's a little crooked, energy level that contains electrons? Well, that'd be the biggest number. 4, okay? Now, what's weird about this one is that 3D actually fills after 4. The reason that happens is sometimes 3D overlaps with 4, and a few electrons get closer to the nucleus. But if you're asked a question about the highest energy level with electrons, it's the highest number. I could ask you this, though. What's the last orbital that filled with electrons? Think you can answer that, Kyle? Take a guess. Take a guess. Orbital would be just D, but you're right, 3D. How many more electrons can orbital D, 3D, hold? Dave? Yeah, 5. Okay? Are you getting it? Yeah? Marty, you okay? Do you have a question for me, really?
Yeah, I think so. So like the 3D or like into like the 3P and stuff.
Yeah.
So each like little thing above it.
Each arrow,
Yeah, that means like 2.
1 electron, 2 electrons.
Okay.
It means this one's spinning that direction and this one's spinning the opposite direction because they repel each other. Okay? Now, we're going to do one step farther. Let's start with, I'm going to use this, electron configuration notation for, let's just do a small one, magnesium. What's the atomic number of magnesium? We should know that. Good, 12. I think that was Connor. Okay, so I want you to do electron configuration notation for magnesium. I'm going to do it too. And then we can check. But I want you to do it yourself. Don't just copy what I'm doing. Try it. Then when you're done, check with mine. Did y'all get this little drawing? Yeah? Now I'm going to show you the next step, the way we can use this information after we have it. It's called orbital notation shorthand. When you get really good at this, you can do this without all the arrows, but it doesn't come easy at first. So when we do our orbital notation shorthand, we go to the lowest energy level, which is 1. I'm going to write 1. Then I'm going to write my orbital, which is S. And then my electrons become a superscript. So I write 1s, it looks like squared, but I would say it 1s2. And then I'm going to put a line through that so I know I've used it. I'm going to go to 2s2. Put a line through it because I used it. What would I put next, Carly? What'd you say? Yeah, good. 2p6, used it. And then I put what I have left, 3s2. I can still answer all those questions about it. Highest energy level is 3rd. How many electrons are there? 2. What orbital is there? S. What's its atomic number? 12. I can figure out all that stuff just from that little thing. All right, let me give you one to try. Actually, first, see if you can figure out what atom that is. Brooke, do you know? Is it zinc? I can't remember. Yes, it is. Good job. Bingo. Way to go, Brooke. All right. I'm going to give you a hard electron configuration. Oh, Tayden. Let's try xenon. Xe. And I want first electron configuration notation. Be very careful to follow your card and to follow your pattern here so that you're setting things up the right way. Maybe I should ask how many electrons xenon has, Riley. How many? 54, okay. Make sure you got the right element. It's also a good idea when you get all done to go back through and count your number of electrons to make sure you have the right amount. Oh shoot, I forgot we start projects Monday. Who goes first? Do you guys remember? Okay. Second? Do you remember your days, people? Okay. Okay. As long as you remember it, that's all that matters.
Are you second? When are you first? What? I gotta do this call.
I can tell you. Hold on.
Yeah,
Finish them up. Oh, Caitlin, she's not here. And then Lexi.
shoot.
I better remind her. Close to finished?
Getting
Okay, we should be getting close. When you're done, stand up. I don't want to make you stand too long.
You want both, right? Or-
Did you do both? Haley? Yeah, I want both.
Okay.
Where do I have it? I didn't do it. There's the electron configuration. You can check that. What?
So like, so you wouldn't go to 4F? Just go to 5?
Nope. You gotta follow your card.
Oh,
You gotta follow those arrows. Gonna run out of room. You guys who are standing, do you agree with me? Did you end in 5P6? Yeah, that's good. Now, there's one thing I was concerned about. Well, I'm gonna wait a minute. We've still got a couple people. Kyle?
I think I kinda like jumped ahead.
You did? Well, we can't have that.
Well, because,
Were you following your arrows on your card?
well, I was looking at the,
You gotta follow your arrows on your card. Because there's a million different ways you could read this, depending upon your personality. One person might read it like this, one person might read it like that and go up, so you gotta follow your card.
that's helpful.
What?
I said that's helpful.
Yes. You gotta follow your card. We'll try another one. Well, maybe not today.
It's okay. Gotta do that.
I got up to 6.
I'm gonna give you one, just one for homework.
There's always next time.
Yeah.
That's what my dad always said.
Listen for just a minute. Even if you're still working, stop and listen. There's always next time. When you do your shorthand, you keep your energy levels together. All your ones go together, all your twos, all your threes, all your fours, all your fives.
I messed up 2 times.
If you didn't do that, then you just fix it next time,
Yep. Always.
okay?
There's always next time.
Let me give you, I'm giving you something really little to try right now, just to make sure you can do it. Potassium, really quickly, everybody do potassium. And then we'll talk about it. Follow your card. If you're done, you can check what I have up front. See if you did better the second time around. Yeah? Then we'll just continue. I'll probably, see where we are on Monday. I may take 10 minutes or 15 minutes each day so we don't lose this. Because otherwise, we've got like a whole week in between and you're going to forget stuff. Marty, did you get this one? Good. Kyle, did you get this one?